Hello everybody, my name is Miss Oliveras and today we're going to continue with our Algebra 1 course. We are in our second lesson and we are solving one-step equations. So what we're going to be doing is solving one-step equations by using the properties of equality. And our vocabulary words will be one-step equations and property of equality. A one-step equation is just an equation that can be solved in just one step, and we're going to be using properties of equality. If an x is a variable, then that means that we can solve it in any of these four forms. The properties that we're going to be looking at are these properties right here: addition, subtraction, multiplication, and division. And these properties are applied on both sides of an equation. So let's start with the addition property of equality, and what it says is that if we have the following type of equation where we have a subtraction, we use the addition property of equality. Why? When we have a subtraction, do we use an addition property? Well, because that is the opposite of that equation. So let's do an example so we don't get all confused. If I'm going to solve x minus 12 equals 4, all I have to do is add that opposite of that number on both sides of the equation so I can cancel it and leave my variable all by himself. And that is all I'm doing. I'm just solving for that variable. So this is a way that we can do it. We have a subtraction right here. And what would I do to cancel that subtraction? Exactly, we would add. So I'm just going to add that number, the same number on both sides of my equations so I can cancel that 12 and just leave that variable all by himself and then solve on the other side. And 4 plus 12 will equal 16, and that is how I would have that variable all by himself. There are a few ways I can do this. Again, I'm going to try to use my touchpad right here. It is not the same as using my tablet, so please be minded that maybe the numbers are not going to be that pretty. And what I have is my variable x minus 12. Please be patient with me here. Equals 4. And another way that we can do it again is by canceling them. So what would I do is I will look for the opposite of that 12. And I would add it on both sides of my equation. Sorry, that is supposed to be a 12. And we know that if I have a negative number and I add the same number as a positive, that will be a 0. And I'll just it will be something like this. And then we have 4 plus 12, that's 16. Sorry for my 16, it looks so weird. And we know that anything that we add 0 to is just going to be the number. So I'm only going to be left with that x, that variable, and it's going to equal 16. So some people may have seen it this way, and some other people might see it this way. So you just do it the quickest and simplest way for you. There is no wrong way. You just have to remember that when you have a subtraction, you're going to use the opposite property of it, and in this case, the addition property of equality. Again, with subtraction is this exact same thing as the addition. In this case, we have a problem that has a addition. So what we're going to do is subtract that number on both sides of the equation so we can leave that variable all by himself and just solve it and simplify it for it. So again, in this occasion, I have c plus 4 equals 9. And all I have to do is look for the opposite of that number. That is going to be minus 4. And I'm just going to subtract on both parts of my equations the exact same number. So I have 4 minus 4, that's going to be 0. It's going to be and I'm going to be left with C plus 0 equals 9 minus 4. And 9 minus 4 is 5. And anything that I added 0 to it is going to be just that number. So I'm only going to be left with that C equals 5. And again, you can do it as we did in the last slide. You just have to subtract that 4 in both sides of the equations. So just like we did with our addition and our subtraction, I'm going to do the same thing with our multiplication and division. All I have to think is, what is the opposite of what am I doing, or what they're asking me of? And remember, the objective of this is to solve for the variable so we know what the variable means. So if I have a division just like this one, and yes, that is a division, what do I have to do to leave that variable all by himself at one side and solve for it? So all I have to do is use my multiplication property of equality, and what I would do is multiply the same number, that is right here, on both sides of my equation so I can cancel them and just leave that variable all by himself. So let's do an exercise. Let's try to do an example of this so we can have a better picture of it. So what I would do is, if I have this type of equations, I have y on top of 24 equals 2, or I can also say y divided by 24 equals 2. All I have to do is multiply 24 in both sides of my equations so that number y, that variable y, sorry, can be all by himself. So I will multiply 24 each side of that equation, and what it would do is just gonna cancel those and leave my y all by himself. So I'm gonna turn that one down and then gonna solve that multiplication. And how much is 2 times 24? 48. Awesome job. And that way we are leaving that variable expressed this way so we know what that variable means. Now we know that y equals 48. Again, we're doing the exact same thing, but this time this is the division property. We have a multiplication. We have a number multiplied by a variable equals another number. So what I have to do here is use my division property so I can leave that variable all by himself and in this part of my equation and just solve for it. So for example, I have 3 multiplied by my variable x equals 24. And what I have to do is divide for that number 3 so I can cancel them. Because 3 divided by 3 is 1. And when I multiply anything by 1, it's just going to be that number. And I'm going to do the exact same thing on the other side of that equation, and I'm going to have 24 divided by 3, and 24 divided by 3 is going to be 8. And then I'm going to be left with x equals 8. And that is how we were going to solve that type of equation. And that is all for today. You do have a homework, and your homework is on page 20 and 21 of your math book. Those are your exercises. Once you have finished doing those exercises on your notebook, please hit that link right here that is on your presentation. It's a hyperlink. It's also on LMS. If for some reason you do not have that link, please send me an email and I'll resend it to you. That is very important for you to put the answers on that Google form because that is my evidence that you are doing your homework and your daily work. Now, another thing that I wanted to add, and I don't know if you guys know, but I have said it before in our class, in our virtual class, is that that book, that Algebra 1 book, that is Holt McDougall Algebra 1 book, it has to say Common Core on the top of the book, on that cover. If this does not say Common Core Edition, that means that is not the book that we are using. The book that we are using is Holt McDougall's Algebra 1 Common Core Edition. That is very important. If you do not have that edition, please send me an email. Maybe I can send you some pictures of the exercises. I'll contact a friend. I hope you enjoyed today's lesson and see you on our next virtual class. Bye!